Welcome to today's lesson on gears. Our plan for this lesson is as follows. First, we'll understand how gears are mechanical devices used to transmit and modify motion from one part of a machine to another. Next, we will work through a specific example of calculating the moments on gears and observe the relationship between gear radius and moment. Finally, we'll give an overview of some of the practical applications of gears. So far, you have learned about the equation, moment equals force times distance, and the principle of moments. You have worked through practical examples applying this principle. With this foundation, we can now introduce gears and how they modify motion and force. Gears are essential mechanical devices found in various machines, from simple clocks to complex industrial machinery. They are used to transmit and modify motion, which helps achieve different mechanical tasks. By employing gears, we can alter the speed, direction, and rotational effect, also known as the moment, of a force. Gears consist of toothed wheels that interlock with each other. When one gear rotates, it causes the other to rotate as well, often in the opposite direction. Now let's look at how gears work. Consider a simple gear system with two gears, a large gear, gear A, and a smaller gear, gear B. These gears are mounted on axles that serve as pivots. When gear A rotates, its teeth push against the teeth of gear B, causing gear B to rotate. Because of the meshing teeth, both gears rotate in opposite directions. Even though the force applied to both gears is the same, the radius of each gear affects the rotational effect or moment. To remind you, the moment or torque is the rotational equivalent of force. It is calculated as moment equals force times distance, where distance is the distance from the pivot. For gears, the distance from the pivot is the radius of the gear. Large gears with a large radius can generate a larger moment for the same applied force compared to a small gear. Let's explore this concept with a numerical example. Suppose that gear A has a radius of 10 centimeters and gear B has a radius of 5 centimeters. Both gears experience a force of 200 newtons. To find the moment on gear A, use the equation moment equals force times radius, which equals 200 newtons times 0.1 meters, which in turn equals 20 newton meters. Now we want to find the moment on gear B, so once again using the equation, moment equals force times the radius, which is 200 newtons times 0.05 meters. We find that gear B has a moment of 10 newton meters. We observe here that gear A, with twice the radius of gear B, has twice the moment. Gear systems often have gears of different sizes to create beneficial mechanical advantages, as large gears, with a large radius, can generate a larger moment for the same applied force compared to a small gear. If gear A is the driving gear, which just means that it is the gear that supplies the energy, and gear B is the driven gear, which is the gear to which the force is directed, gear A will turn gear B faster because gear B is smaller. Conversely, even though gear B rotates faster, it generates less moment than gear A. By adjusting the sizes of the gears, we can fine-tune machines for varying speed and torque requirements. This principle is widely used in applications like bicycles, where changing gears alters the effort needed to pedal and the speed of the bike. In fact, there are two key areas where gears are used to optimize mechanical systems. First, speed multiplication. Large driving gears connected to smaller driven gears increase the speed of the output. For example, in a clock mechanism, different gears enable the hands to move at different speeds. Second, torque amplification. Here, small driving gears connected to larger driven gears increase the torque of the output. This is commonly seen in areas like winches and gearboxes, where more force is needed. Understanding how gears and moments interact allows us to design and use mechanical systems more efficiently. By knowing the relationship between force, radius, and moment, we can predict how changes in gear sizes will affect the overall performance of a machine. This knowledge is crucial in engineering and everyday applications like biking, driving, and using machinery. Watch the rest of the GCSE physics course at Sophos Education